All right, good evening, everyone. This is officially the second day of our kinematics unit in the AP Physics 1 course. And today will be a more fun day compared to the first day. We'll be doing Kahoot, doing practice questions together, and it will be mostly the students, not really me talking. But before we get to that, I would like to answer any questions that you might have not been able to ask last time, because when I was editing the videos, if you haven't seen my post on ED, many of you guys were waving your hands on the camera screen, but I couldn't see it because I was looking through the chat. So I apologize beforehand. So if you guys have any questions you weren't able to be answered from last class, please put them in the chat again, and I'll be more than happy to answer them. All right, Derek, you have a question?
Yeah, my question is, what's the delta thing again? What's the meaning?
Sorry, can you repeat your question?
Do you know the delta thing in the equation?
Oh, okay. So the delta symbol is a triangle, and it represents the change or difference. It's like, remember I said about the car, right? It's traveling like 15 meters forward and then comes back 10 meters. That delta basically is like a symbol of saying the total change, which is also like this for displacement and for time. It's basically like taking the final value and subtracting it by the initial value to find that change. It's like if I have a number 5 and 7, that change would be 2. And so that delta symbol just represents like, okay, we're finding the change in that value, in that variable. Does that answer your question? Okay, James, you have a question? Okay.
No, my dad's name is Derek. I'm James. So
Oh, okay.
yeah, I just changed my name.
Okay. All right, so if there are no questions, I'm going to be doing a little quick overview of what we learned last time, because I know some of you may have conflicts with other things. And I'll also be talking a little about representations of motion, like the graphs, because we didn't really cover that. And I'll be doing a quick derivation of the kinematic equations that you saw last time, because in AP Physics, it's not really about the numbers, but the relationships. And definitely on the test, they have a lot of derivations, and there's usually the answers aren't like what you see on a normal math test, like numbers. They're more of like variables and equations that you have to find out for yourself. All right, so the first thing, as I said, we'll be doing a review, right, of representations of motion and basic definitions like vectors and scalars, right? And then after that, we'll be doing the Kahoot. And lastly, we'll be doing the Q&A session, and as well as a practice question set if we can have time for that. All right, so first I would like to go over the kinematic equation derivations. So let me just annotate it. Okay, so we know that acceleration, right? Last time we said it was a vector, and that is equal to the change in velocity over time, right? And James just asked the question, right? What does delta represent? Which is this symbol right here. And that symbol represents the change in something, right? So if I have an object, right? It's going 5 meters forward, and then it comes back 7 meters, right? So this would be a +5, this would be a negative, assuming that forward is positive and back is negative. Then our change, right, would actually be equal to 2, -2. Because, right, we're going forward 5, but we're coming back 7. So our actual distance from here to here is actually 2. And since it's backwards, it's negative. All right, so just to clarify what the delta represents. So now I'll be going into the kinematic equations. So when we have delta v, that means the change in velocity. And that's equal to vf, which is the final velocity minus the initial velocity, right? And then that equals delta v. That's what we mean by delta, which means change. And that's over time, because you can't just delete a time, right? So this equation vf minus vi over t is equal to acceleration. It's just a different way of writing our equation, delta v over t, right? And so what we can do now is we can multiply both sides by time, right? To get rid of that denominator. And now we have t times parentheses vf plus, sorry, should be a minus. Minus vi equals at. And so now we can distribute this to both sides, right? So we have vft minus vit equals at. Okay, and wait, never mind. I'm sorry. After we distribute after we multiply both sides by time should actually cancel out. Sorry for that confusion. Right, so after this, the time gets canceled out, and we actually get vf minus vi equals at. And so what we do is we put vi on the other side by adding vi on both sides, and we're left with this equation: vf equals vi plus a. And this subscript on the bottom, the I and the F, just means initial and final. It's just a way of simplifying our math, so we don't have to write the actual words. All right, so this is our first equation. Vf equals Vi plus, just erase all this. All right, so we also learned from the graph last time, right? If we have a y and the x-axis, right? And let's say we have a graph like this, it's a rectangle. To find the area, you basically do base times height, right? And so your base would be x and your height would be h. And that gives you the area. Okay, but the thing is, let's say we have a triangle, right? And that becomes, area of a triangle is 1/2 times base times height, because it's the half of a square. So we would actually have 1/2 x times h. Something else that I also have to go over is something called average velocity. And average velocity is basically a term that represents how fast something is traveling with respect to a distance that they give you. But we're under that circumstance, we're assuming that that there is no acceleration, and that the object is just traveling at a constant speed. And that's something we call an average velocity. So that is really just vi plus vf divided by 2. Okay, so that's what average velocity is. There's also something called average speed, which is just your distance divided by your time. And your average velocity is your displacement divided by your time. Okay, so knowing this equation, right, of average velocity, and we know that distance over time, right, that gives you average velocity. And so if we rearrange the equation, we can basically say that the distance is equal to the average velocity times time. So we have distance divided by time equals v average. And so we could basically multiply both sides by time, right? And time basically gets canceled out because it's in the numerator and denominator, and then we have time on this side. So we end up with this equation, distance equals v average times time. Okay, and v average we just saw is this equation, right? It's vi plus vf divided by 2. So we can actually write this equation as we can actually write it as 1/2 vi plus vf times time, and that gives us our distance. Okay, and using this equation above that we just derived, right, we can isolate the variable. We can actually substitute the variable vi, since we know right here. We could just do vf minus at equals vi. Sorry, we can actually just leave like this, right? We just derived it. So we can just put this in here. So we get 1/2 vi plus vi plus at times time equals d. And you can simplify this equation. So let me just bring this up here. Just bring this up. So you get 1/2 times 2vi plus at equals d. And so your final equation is d equals v initial times time plus 1/2 at squared. And this is also another kinematic equation that we use for projectile motion and kinematics. Okay, there is also another equation that you have to know. It's called Vf squared equals V naught squared plus 2a delta x. This is the third one that I usually use for AP Physics. When I took the test, I just memorized these three. They were the most helpful to me because you could basically rearrange them to get another kinematic equation. And so I don't necessarily have the time to show you the derivation for the third one because it's more complicated, but I can tell you how to use these. So for the first equation, right, I'll give you a typical scenario. So let's say you have a car, right, and they tell you that the initial velocity, right, is equal to 5 meters per second. And then they tell you the acceleration is also equal to 2 meters per second squared. And so they ask you, what's the final velocity after 3 seconds? So what do you think, which equation do you think we should use? Let me just label this. So let's make this equation 1. Let's make this equation 2 and this equation 3. Which equation do you think we can use? Just type in the chat. Okay, I'm seeing a lot of ones. Sorry, Daniel, if it's kind of messy. After this session, I'll definitely show you an article of all of them. Actually, later I can just go back a couple slides and show you the actual ones. Okay, so I see a lot of ones, and number 1 is correct. The reason why is because you know VI, right? They tell you VI, so you can check that off. They tell you acceleration, you can check that off. They also tell you the time. So basically, you can just plug all these values into the equation, and you get your final velocity. And then now there's a different scenario, right? So let's say I want to find the distance. I want to find the distance it travels. Okay, but I don't tell you the time. I tell you the final velocity. I say that the final velocity is equal to 6 meters per second squared, right? And I don't tell you the time. So which equation, if I was to find out how far it would travel, which equation do you think I could use? Yeah, I'm seeing a lot of threes. That's exactly correct, because we do know final velocity, right? We do know the initial velocity. We also know the acceleration, but we don't know this value. And so what you can do is you can substitute all these values in, and you can isolate the variable delta x to find it. And lastly, let's say if I did tell you the initial velocity, right? And I did tell you the distance. So I did tell you, okay, so the distance it would travel is 9 meters, right? So I tell you the initial velocity, I tell you the acceleration, and I also tell you the distance and final velocity. Which equation do you think I would be using? Yeah, so I think you guys get it. It is equation 2. So the thing about kinematic equation is sometimes the question doesn't give you a variable that you want. And so you can use a different equation, right? One of these 3 equations, you find that value. And after you find that value, now you have one unknown. So let's say a problem, right? They ask for you the distance that a car will travel, but they only tell you the time, the initial velocity, and the final velocity, right? So what you would do is you would use equation 1, right? You would find out the acceleration since you know the VF, the VI, and the time. Then using that acceleration, now you only have one unknown, because before you had 2 unknowns. You had the acceleration unknown and you had the distance unknown. But since you have equation 1, you can find out acceleration and now you only have one unknown. So now you can use all these values and substitute it into another kinematic equation to get your final displacement that you're finding. So I think most of you get it. Later, I'll show you sorry if my work is very messy, but I'll show you how it will look like in a very clear manner. And now I just want to talk a little about representations of motion. Okay, so remember last time I talked to you about a car, right? And it was going up. It had a velocity, right? Of, let's say, initial velocity of 2 meters per second, and it has acceleration of 3 meters per second squared. And we have this we have these graphs, right? This is position versus time. And then we have the velocity versus time. And then we also have the acceleration versus time. Okay. How do you think these graphs will look like? Let's start off with position versus time. You could either say it's linear, which means it's a straight line, or you could say it's exponential, which is a curved line, or you could say it's just constant, like a straight horizontal line. Okay, I'm seeing a lot of exponential. And why exponential? If you could put that in the chat. Any answers or explanations? You could take a guess. It doesn't have to be exactly correct. Okay. Okay. Accelerating, yeah. Velocity is changing, yeah. Yeah, so I agree with Jake and Ariel's question, Ariel G's response. Yeah, also Jaden, S squared. Yeah, so sometimes if you don't know why, you can also check the math, right? Before I said acceleration, its units is meters per second squared. So if you see a squared inside the unit, it's most likely exponential, right? Because x squared is an exponential relationship. Okay, and the conceptual reason why it is exponential is because its velocity is changing, right? And so basically what's happening is as the car, every second that passes, the car is moving faster and faster and faster. And so its position, which is basically the distance it travels, is getting faster and faster and faster. So you start off with like a very slow line, but then soon as the velocity goes up, it's starting to curve up really high, right? That's an exponential relationship. What do you think the velocity versus time graph will look like? Again, you can say linear, constant, or just zero slope like this, or exponential. Linear, okay. Do you think it's going to curve up? Do you think the line's going to have a positive correlation or a negative correlation? Assuming this is positive and this is negative. Positive, okay, I see a lot of positive. Okay. Yeah, it would be positive. The reason why it wouldn't be negative is because if you have a line going like this, you're basically saying that your car is accelerating backwards at like what, 3 meters per second squared? And so your position versus time graph would actually look like this. So that would not be correct. It would actually be like this. Okay? So finally, what do you guys think the acceleration versus time graph is? Constant, okay. To specify, what constant is it going to be at? Like what value specifically? Oh, sorry. 3, okay. Yeah, 3 meters per second squared. Always remember your units. Always remember your units. So it will look like this. Okay, so I think you guys get it. We'll have practice later, definitely, but I just wanted to review on all of this. And so without further ado, okay, so something I want to go over in AP Physics 1 is lab equipment, because I know the coronavirus, not all of you have access to labs in your schools. But basically in my lab, we would have a lot of lab activities. Like one of them was like measuring the spring constant of a unknown spring. Another one would be a flying pig, which would basically be like a one of those electronic pig with flapping wings, and then they would tie it with a string to the top of a ceiling, and they would give it a push so it would just go in circles, and it's very complex with some rotation. Um, but basically, one of the major sensors that we use is something called motion sensor. And what a motion sensor does is it sends out like waves or yeah, it basically sends out waves um, literally every second or even smaller than that. And basically, if an object is moving towards it, it measures the rate, the time at which those waves come back. So like it's kind of like echolocation, like how bats use them. They try to track their prey, but just like motion sensors, they send out those waves and they sense how quick a object is moving towards it. All right. And also on the screen, it says measures an object displacement with respect to time. Okay, and just to go over, right, last time we talked about vectors. Vectors are basically scalars, and they have magnitudes. They're not like scalars, but they have magnitude and direction. Scalars only have magnitude, and magnitude is just a physical quantity. It's like how much of something, right? Um, I'll just give you a quick example, right? So let's say I have this line, right? This object is moving in this direction. And then I have another object that's also trying to reach this point, but it goes like this, right? It goes in curves. The displacement would actually be this straight line because it's the total, it's the difference, right? This is the final position and this is the initial. It would be the final position minus the initial, and it would give you that straight line. The curved line would give you distance. It's the amount of the total length of the path travel. Okay. Um, what else? Okay, and also average velocity, as I said before, average velocity is displacement over time, and average speed is distance over time. Also get that. What else? Okay, I think that's about it. And let's get started on the Kahoot. So if you guys don't know how Kahoot works, it's kind of like a multiplayer game, and obviously it's not like Clash of Clans or something. It's like an educational game, obviously. And so, what's how it works is you basically I will share a screen with a code, and you would input that. You just if you have a phone or something, yeah, you would like Nina shows on her camera. You would just go on your phone and put it in Kahoot or search up on Google, and it would just be Kahoot.com, and then you would input that code that I show on my screen, and then you would join the group or the team that I made. And basically using the code, I would basically click start, and then an image or question will pop up on my screen, which will show it on your Zoom, and you have to input the red, blue, yellow, or green choices on your phone. Okay, and also if you answer fast, you get more points, and if you answer slowly, you obviously get less points. Oh yeah, definitely. If do you guys want music? Put in the chat if you want music or not. Okay, actually, to make this more organized, just go in your participant section. If you want music, press yes. If you don't want music, press no in the participant section. This is really hard. It's like almost half. Okay, I think most people want music. So I'm gonna put it up, but I'll make it lower. Oh yeah, let me see if I can do that. Do any of the co-hosts know how to turn off the chat? Because I'm not really sure. All right, so there you go. That's the code. Try to put your real name because we don't want to get too creative in here. All right, so we just give it one more minute. Who is Joseph's mom? If you guys keep on putting like random names, I will have to delete you guys from and make you guys rejoin. So Russian Joseph's mom. Um, okay, unless you're actually your son is named Joseph, then I'll let that go. Russian hacker, sorry. Melon bread, sorry. You gotta rename yourself, your real name. Someone, sorry. Oh, sorry. Uh, I accidentally deleted one of you guys. Charm? Okay, please. No one's called Charm. Unless I don't think anyone's name is called Charm. Okay, 30 more seconds. All right, in 5, 4, 3, 2, 1. Begin. Yeah, be careful when you guys read it. It's kind of tricky. Speed is a scalar. It is also distance divided by time, and its units in AP Physics is meters per second. So actually, all choices are correct. All right, Nina K, first place. If you guys are confused with the symbols, V is just for velocity, T is for time. And if there's a P dash T, it's just position versus time graph. I presented it in my slides. You guys should know it. Think about scalars and vectors. Which ones are scalars? Which ones are vectors? Okay, that question might be confusing for some of you. Remember, acceleration can be in the negative direction, right? I can be accelerating backwards. I can be accelerating forwards. It just matters whether I specify forwards or backwards. So it is yes. Think about the relationships we talked about before: exponential, linear, constant. Okay, d is distance, s is speed, and t is time. Think about where line A and line B intersect or meet, that point. And then think about what slope represents, right? Slope is rise over run. Okay, that question was a little tricky, right? Remember we talked about distance is not displacement, right? The graph was kind of like going up, then it stayed like horizontally, and then it came down. You're not actually supposed to add the distance on the top because it's actually staying at 15 meters for that period of time. You're only supposed to take 15 and times that by 2, which should give you 30. We'll go over it later. This is something you should all know. Okay, great job. Remember, you're taking the slope of point D and its previous point, not all the way from the bottom. It's only from the previous point. 5 more questions left. Sorry, we're just speeding it up because it's almost time. Two more questions. All right, congratulations to Angeline for 3rd place, Rachel for 2nd place, and Charm for 1st place. I hope you guys all enjoyed it. Also, congratulations to Jake for 4th place and Charlie for 5th place. I'll be staying on for if you have any more questions. I understand a lot of you have classes to go to, so you are free to leave now. And I'll definitely post a recording on ED. The first one is already on there as well. And